Hello kitties, it's me again with some fun and interesting little tidbits on a stupid toolbox. Some stuff I'd like to show you anyway. Is my thing not work? Oh, I see. I guess I must have restarted. You know, it's funny, as the other user, I've been logging on as this other user for developing stuff on the math side. Working now? No. And it's so much faster than this one. It's unbelievable. Okay. It's hidden. And I believe it's recording. Now, what I did was, as a demonstration of the topic, the vector sprite dynamics, what I did was in the polygon mode, now that I know inside and outside, now that I know it inside and out, I put my little debug function in there, and so the polygon person is innocently drawing their polygon. Meanwhile, when I hit my space thing, I steal it. I turn it into a sprite. Okay. So now we can maybe draw another one, different color, and I want to let this one go, and it's going to collide with the other one. You see? So now you're seeing collision detection at work for vector sprite. Always seems to collide in the same bloody spot. Let's get another one going. Green one. I want to wait till, there we go. You see how it's not always perfect with the difficulty with sprites, as always, is that if they get together, they're remembering each other as the background. So you've got to invalidate the part of the background that is overlapping with two sprites, and that has to be redrawn externally. And that's what I'm doing too. Otherwise, it would just be a complete mess. But as you can see, actually there's a little gravity going on here, so they will they won't go faster per se, but there's some amount of all the randomness in their motion. I could increase that. Here's my, now let's see now. I exit. I'm tracing out the velocities and stuff, but it doesn't appear as though I have a memory leak or anything. Now I just happen to know that the animation timer is 40 milliseconds per tick. And this is the initial Now, I'm not sure if I should divide by this or the square, but I think that's fine. If you want, I want to have a velocity in pixels per second. See, what I should do is I should change the frame rate and see that everything moves at the same speeds. Suppose I would like my velocity to be, here I've said 100, and I mean what I would like that to be is in pixels per second. Now, the frame rate, frames per second, I've just said is 25. I believe that's correct. If it's 40 milliseconds for one frame, one frame is 40 milliseconds. So to get 1 second, right, how many, I need to multiply 40 times 25 is equal to 1,000, right? 4 times 25 is 100, times 10 is 1,000. So 25 frames is equal to 1 second. So there are 25 frames per second. And where I set the timer, where do I set the timer? Start ticking here. And that's set to 40. Okay. Now what I could do is, if this was a variable or something I could read, I could put it as in my getting more and more busy globals.h as a number defined, the frame rate, and I could specify this in frames per second. Suppose I want 60 frames per second. That means I got to adjust this. If I want 60 frames per second, that means that 1,000 milliseconds is equal to 60 frames, 60 ticks. Right? I want 60 of these every second. So I just 1,000 divided by 60. That's 100 divided by 6, which is 50 divided by 3, which is about what? 60 is 20. Well, I can just say 50 over 3. Did I just say 3? 100 over 60, 50 over 3. And why do I think that's good? I'm thinking 15. There are no 3's in here. It's just 5 times 2 times 2 times 5 times 10 times 5. Oh, sorry. I want 60. So 50 over 3. Oh, so frame rate, wherever the frame rate is set at, number of frames per second, and we say 1,000 divided by frame rate. Is that right? have to be. If frame rate is 25, 1000 over 25 is 40. So it works in that case. Okay, well, leave it at 40 first. I'm going back to this here. I don't need this. I could cast it as a double. So now it should be the same. I just want to make sure that I've done this correctly. So increasing the number of ticks should have no effect on the speed. It may have an effect on the smoothness of the of the motion. Most games, like of course, running using DirectX or something, will run something like 100 frames per second, maybe 125 frames per second, although you'll never see 125 frames per second because your monitor refresh is less than that. So I'm not exactly sure why they bump it up so high. Maybe it's just for like really high-end. Well, you connect a high-end system. It doesn't matter. With these LCD screens are limited in their how many redraws they can do per unit time. I mean, there's a physical limitation, but of course you could use a cathode ray tube, and those things can have a very high refresh rate. But you wouldn't notice it. I don't know. Not sure what the advantage is. Because the more time you have between frames, the more time you have to complete whatever computations you need to get done before you're asked to display it. Here I'm doing a collision detection. I'm trying to be as efficient as possible, but remember that it's two polygons, and when they do intersect, then I've got to walk through every one of my sides, and for each of my sides, all of the intersecting one's sides. However, once the collision occurs, then they're moving away. Here's the famous computation, the moving away computation. So to avoid doing this again, what I'm doing is, well, first, I've invented something called vector sprite, which derives from this copycat is the sprite object I use for clicking and dragging things around. It takes whatever it intersects with and copies it, and then removes it from the coordinate system's internal manager. So it handles its implementation of drawing is to simply take the object that it's grabbed and let it draw itself. And that's what I want it to do. So I'm a copycat, but I also have a static list of all objects of this type around so that I can, every refresh I can do a frame collision detection. And I'll show you that in a minute. Just see that everything is working. That looks correct. I don't want them to be intersecting. It shouldn't matter really, but we get a red one. You see, it's quite good in terms of the accuracy. Now, these collisions, of course, could be more how should I say? You could do more with the way that, like, see here, that was on a corner, and that could cause rotation. That's torque, right? And it's easy to figure that out. You know the central spot, and if the collision, now what's happened? It's paused. Probably the recorder. The collision is going to occur either. No, that's amazing. Look at that. See, it's computing it all, but it's not drawing it. I wonder why. See, I'm not even getting a. Maybe if I go to full screen. It's running. No, I can't think of anything building up. Stop it. It seemed to be going great, and then let's do it in full screen. But it's not really full screen. That's just a full screen usually means like full access to the hardware. This is an illusion. I'm not getting any, direct draw hardware acceleration here. This is just GDI. But still, it's nothing like this without that bloody recorder running. The recorder's eating up all the time. It's still running, see? Well, sort of. Stupid recorder. You can see here. It's computing the situation, but it's not able to display it. Because, like, at this point now, I guess the background is being redrawn. Now, do I have a critical section that could cause this? Like, I should get a, now that's gotta be one of the funniest things I've seen in a long time. Here I am in full screen mode, and come on. What I want to do is when it's, well, I can do it now. It's hung, right? Yeah. Break all. I just want to see if they're all waiting on some. Okay. Good. This thing is that's just the animation timer, and it just got a message, and maybe these are bundling up. and have too many. So if I reduce the frame rate, then I won't get a backlog. Where is that? Global. Let's try. Yeah, 40's higher. 40 before was milliseconds. So now we reduce the frame rate, we'll be back to what we had. So that was working. I think we're moving at the same rate, even though we had nearly doubled the frame rate. And of course, that's global. I could make it into a function. It is kind of a thing that a number one would want to play around with. So I should probably make it a function. You can make it a double. No, I can make it a UN. I'll just put that in something like here. $25 what we want. Could read something from the registry. And great. And you can just modify something in the registry, and if it's calling this function every time, then you can change it on the fly, even as the program is running. You could. It's fast enough to read from the registry. I mean, this thing gets read in every time it sets up a new wait, right? So it's on human time order. And the other things, well, the initial, they don't read this constant. The sprites don't read this constantly. Only a new one that I would add would correctly read it. The rest would speed up or slow down. I wonder how I could make it, this thing could return a reference to a uint or something like that. And I don't know, whatever, we'll see. Okay, well, while that's compiling, let me just try and show you again how it works. Since this is of critical interest to most people. First off, dynamics. The polygon object, I'm taking its center point as its position, but the rectangle object that this is ultimately derived from, that position is the upper left corner. So I subtract the width and height from it from the rectangle position. So that means that this point, the value of this point will be in the center of the object. Time to see it go again. I wanted it actually a little different color. More complicated object. So eventually they get separated out. Now, does this help? Let's add another one. Big mistake. Well, it should come back. It's still computing, you know. It's just not able to draw. I got it. No, I don't. I tried to bring up the dialogue to add another one. Ridiculous. It's just the recorder. It runs fine. I could try. I know what to do. What are the chances? I could try a release. I haven't tried. This will be the first time I've ever built this thing for release, and I have my doubts that it'll build. I've changed so many things. Even if it does build, chance of it working, I don't know. But anyway, back to the dynamics. This is the typical scenario for an object, a dynamic object. Position, velocity, acceleration. 3 Newtonian variables. Their meanings are their meanings. This is the current velocity in some units. Acceleration should be in the same units. If it's pixels, you know, if this is pixels per second, this should be pixels per second, and there should be pixels. Okay, well, pause is always in pixels, so these should be in pixels. When an update occurs, okay, an update is sort of asynchronous but regular. If the update is not regular, then you have, you have to compute the time between successive updates in order to figure out where you are. But in my case, I have a frame rate, and that's regular. The position. Now you might think that your position would increase by your velocity times the time. I've computed this velocity in such a way that adding one tick corresponds to one velocity units of. Is that right? It seems to be correct. Position should be velocity times time, right? The time that's elapsed since the last update. But that's been taken into account already by using the frame rate, right? Where I compute that. Now velocity here is what I want it to be, 100 pixels per second. And so that means that I would like to figure out how many pixels I should move per update. So I take the pixels per second and divide by frames per second, and that gives me a value in, well, pixels per second, frames per second, pixels per frame, which is what I want, right? How many pixels should I move per frame? Okay, so update comes along, and I should add my velocity in pixels per frame. However, I've been accelerating throughout that interval, and if you recall from high school physics, and most people get this wrong, most people just add the velocity and then increment the velocity. I have incremented the velocity by the acceleration, but you have to take into account the fact that an interval has elapsed during which the velocity theoretically was increasing. So the velocity, your position, if you recall from high school physics, position equals the average velocity, right, times time. Average velocity over some interval. If it's constant acceleration, if acceleration is constant, then average velocity equals v1 plus v2, so like initial velocity plus final velocity over 2, right? Now my initial velocity was this, and my final velocity is this, velocity plus acceleration, plus the acceleration, so that becomes v1 plus v2 is v1 plus acceleration, right? This here is the second term over 2, so that gives v1 plus acceleration over 2 times nothing. Okay. Really, there's a ton. This here is a rate of change of velocity per unit time, and there's an unseen delta t here. The delta t here times this gives something in units of velocity, and so in fact this is in units of velocity. And time, of course, is one frame, and so that's why you got to add this little bit. I had a test program that didn't do that, and that's basically how I discovered that probably me and everybody else in the world has been doing it wrong. Oh dear, no. There are a bunch of registry things that we set up. I could just copy from. There's something called data dir, root dir. That's all I gotta make sure I have. Okay, well, I gotta let it crash first. What did I just? Oh. I gotta let it create the default settings first. And it's not gonna find the data files. Like there's an image, the control panel has an image, a picture, a bitmap picture, and there's this ini file for the key sequences when I want to enter funny characters in. Okay, it's running, but see, there's no picture here. It's just blue. But that's okay. That's what it takes its current directory is root dir. Okay, now we got our picture. No, this is going to work. It's working. Green. Okay. Let's add another one. Seems to be going a bit better than the debug version. Well, these are too big. Start over again. And make them smaller. Name your color. Full screen. That's the one that really burns you in debug. Okay, come on, you can go. Well, okay, with the recorder running, it can do this many, and that's about the limit. And it can barely do it. You can do one less than this. 5. Okay. Trust me though, without the recorder, it'll run. It runs nice and smooth. Now, I've wasted too much time just playing because it's fun, and I want to explain this simple thing once again. So that's how you get your current position is normally velocity times time, but since there's acceleration, you have to add a little extra term due to the acceleration between frames, and then your velocity increases every frame by whatever you decided the acceleration per frame is. Then set your position to the new position. Now, this get object comes from the copycat sprite object I'm derived from, and that's needed for reinserting objects back into the grid when like I pick up a polygon or something and I put it back in, I have to get it out and add it back. Now, these boundaries are the boundaries of the graph, the coordinate system boundaries. So if I've broken it up into 4 segments, I vectors. I have to add a little bit because there's another part of the code that tries to prevent things from hitting the left-hand wall, and it has the effect of sticking things to it. So I move that away slightly. So this first point is nearly the top left corner, and then point 1 is the right and top, so that's going around the square in a clockwise way. The next is the bottom right, and then the third point is the bottom left. So 1, 2, 3, 4 points, 4 vectors. So this is just a check to see for a wall collision. If the segment happened to be 0, which is the top, and the velocity was negative, these coordinates are in screen coordinates. So negative velocity is y velocity is up. Then I just toggle the y velocity. Otherwise, for the segment 2, which is the bottom, if the velocity is positive and I've overlapped with that one, I've intersected with that one, then toggle the velocity. Similarly for left and right, nothing for that. Now I've got this G list all sprites. Okay, now this is probably not the most efficient way to do it, and probably why it's slowing down, because every one of those sprites is walking through the entire list checking for collisions. Whereas really, if I've checked 1 and 2, then there's no need for 2 to check 1, right? I'm doing double the amount of checks required. In fact, in this case, it should be like there should be one kind of manager that walks through the list and correctly only does each pair once. I'm not going to maintain any flags, I'll just write a manager. But anyway, for a quick and dirty hack, this works. Now what I've done is I'm moving into the reference frame of this object, this particular sprite. So the relative velocity of that, the sprite I'm looking at, which is not me, is its velocity minus my velocity. So that is, if it was moving at the same speed as me, the same velocity, it's directional, then in my frame of reference there would be no relative velocity. Well, it's not really relative. Difference, the position delta, whatever. The distance from me to it is a directed vector towards the sprite, towards the other, towards that. These vector differences are always a minus b is a directed line, a directed vector from A towards B. No, I don't have to run that thing. I just wanted to draw the line. Okay. Now, this step here is checking to see if our rectangles intersect. That is, the bounding rectangle that you saw before that bounds the polygon. If those don't intersect, then there's nothing to do. And if they do intersect, then this returned rect is the rect of intersection between the rectangle of the two objects. And in that case, what I do is I tell the coordinate system to redraw itself. It's actually got nothing to draw except for the coordinate axes, right? The sprites are not part of its draw routine. And then invalidate just this little bit. I don't think that should take too much time. It's drawing from memory to memory, nothing to the screen. Although I probably shouldn't invalidate these during this loop. I should probably accumulate them and then do all the invalidating. Again, needs a manager, right? Nobody's in charge here. Although, no, there's no way to tell. You need an outer thing that can take care of this stuff, right? It's like when you're dragging a window around and you have all those controls that you want to reposition. You don't redraw them during the move. You wait till it's settled and then redraw. Okay, but whatever. That's that aside. Take the dot product of the relative velocity of that with along the line segment between the two objects. If that is a positive number, then that means that it turns out it's going to be one way or the other. If that's positive, that means that the object is moving away from me and there's nothing to do. If it's negative, it's coming towards. Now it's just a matter of going through. I'm a polygon and I have a bunch of points. I go through the points, P1, each pair of points, and there's an intersects with member of a polygon graphic object that takes an I vector parameter, and I'm just calling that. And now if there is an intersection, this is the tricky bit, how to decide what do you do, how do you do the collision? Well, I'm in my own frame of reference, so my velocity, as far as I'm concerned, is 0, right? And this is the velocity that the thing is moving towards me at, right? Well, so what I want to do is acquire that velocity from the other object. I'm assuming an elastic, head-on elastic collision. It's not a good assumption, but assuming that, I'm going to acquire all of that velocity, and then to put me back into, or to put this object back into the real world, I have to replace this amount that I had subtracted before. Well, I haven't subtracted it from myself, but I have from the other object. So the other object's velocity towards me is the relative velocity plus the amount that was subtracted, and that gets added back in here. Its velocity following the collision what I do is that in the frame of reference where I'm standing still, let's see, now I'm reversing his velocity. Shouldn't this just be 0? But I'm setting his, okay, to minus that. Okay, this one's not a plus equals thing, right? This is just assignment. So I'm taking away the amount that I acquired. I'm removing from his velocity. So if we're in my frame of reference, the other object would just stop moving altogether, and I would move away, just like a head-on collision with a pool ball. But then to move back into the real world, the effect is that I've subtracted that much velocity from it, and this just goes from relative back to non-relative, and that's its new velocity, and then break and check the rest. I explained that. I have no idea if you understood what I said, but you can always rewatch it and try for yourself. Okay, see ya.